Hey guys, welcome back. In the second lesson of the official Bolt series, we're going to start our character controller that's going to allow us to move our player around in our game world. To get started, first of all, let's talk a bit about what we need to do. So to create logic and to actually lay out our logic, we're going to use a graph inside of Bolt. There are two different types of graphs we can use. We can use a flow graph or a state graph. A flow graph is what we're going to be using most of the time. It allows us to simply drag and drop our little nodes around to design and lay out logic. Fire off an event, something happens, that type of thing. A state graph is a state machine. It helps you decide what state to go to and when, and we'll talk about those later in the course. For these graphs to execute, we have to create a machine that will actually run these graphs. So we're going to do that on our player, as our player will have its own flow machine, as we'll be laying out our logic in a flow graph. So I'm going to go to Add Component, and I'm going to add a flow machine to my player. That adds a variable component and a flow machine component. And now by default, I have the source selected as macro, and I will be using a macro for this. That's going to create the graph in a reusable file. It's going to be a macro file that we can use elsewhere, and we have to use it for our prefab for player, so we're going to leave that as a default. And then for macro, I have none selected. I don't have any macros in my game, so I'm going to create a new macro by clicking on New. And I want to store this in my tutorial folder in a folder called Macros, and I'm going to call it Player Controller. And that added the player controller as the macro for my flow machine. I am seeing the start to this flow graph. We have a start event and an update event. Now for this, I'm not going to be using the start event, so I'm just going to get that out of the way by hitting the delete key. I do not need that. And I'm going to work with my update event. And if we look on our player object, we have a rigid body 2D already added as a component, and we're going to use that to control the movement of our player. So what I want to do is I want to detect if I am hitting the left button or the right button to go left or right. And we're going to do that by using the default Unity axis for horizontal movement. This works on keyboards, it works on controllers. If you hit the left option, you're going to have a negative value. If you hit the right option, you're going to have a positive value. And you use that to decide which direction you're moving in. So I'm going to add this unit to my graph here. Update event, that's a unit. I'm going to add one more unit here by right-clicking. And I'm going to type in get axis. So we want to get the horizontal input axis. I'm going to go down to input here and select get axis. And now you'll notice this one's dimmed out and this one is not. And that's because there's nothing that actually activates this node. It's just there. It's not being used for anything. If I can toggle this off by clicking the dim button here in the toolbar, so we can work with it that way. But what you'll see is if I were to hook this up to my update event, it's no longer dimmed out. That's because it's actually being used for something. I'm just going to right click to get rid of that connection for now. And the axis that I want is called horizontal, capital H, horizontal. That is the horizontal input axis. And what I want to do is I want to use that value to actually move the character. So if we're going to the left, it's going to be a negative value. If we're going to the right, it's going to be a positive value. So we're going to move the character by actually applying a velocity to the rigid body of the character. And to do that, I have to interact with the rigid body 2D. Type that in, hit enter on rigid body 2D, and see all the exposed options here. What I want to do is I want to go down to find velocity down here, and I want to do the set velocity. Now I could have typed in set velocity myself, but I want to find it this way just for now. So set velocity, click on that. Now I have the set velocity unit here. So what I want to do is I want to pass this value in as a vector too, so an X and Y value. We don't care so much about the Y right now because we're only moving left and right. So I have to create a vector from this X value. So I'm going to drag out on this node here. I'm going to select the node, drag out to the left, and I'm going to let go. This allows me to create another unit based on the type it's looking for. So I want to create a vector too, an X and a Y. And this allows me to drag in an X value and a Y value, or define an X and Y directly on the unit. So what I want to do, obviously I want to take this value from the horizontal input axis and I want to drag it into the X slot on that vector too. And the Y, again, we're going to leave it for 0 for now because we do not want to be moving on the Y. And now I have to actually hook up the set velocity unit here so it actually knows when to do something. Update is fired every frame. So if I were to drag this flow control into the input flow on the unit, now every single frame, set velocity will happen. And it will happen based on the values that we create to pass in as the vector. So let's see what happens here. Now, when I click play, you see the graph goes into this runtime mode where you can actually see what's happening. Everything is blue, which means everything is activated, everything's doing something. And you see these little dots flying through showing you where the connections are and how that's working, which is pretty cool. Now, you see this little icon right here with a 0 next to it, and you also see the vector. That's showing you in real time what the values of those properties are. So if I were to move by hitting the left and right arrow key or A and D, if I go to the right, you see that changing. And obviously my character is moving. Just like that. Pretty cool, but we're moving really slow. So what I would like to do is take that value and multiply it so we can move a little bit faster, right? I want the positive and the negative value to still be positive and negative. I just want to move faster. So what I can do for that is take the output of the input here and drag that out, and I want to simply multiply. So I'm going to click on the multiply unit here, and I can multiply A by B. So if I were to set this to 5, and I'll just take the output of that, A times B is equal to, and put that in the X port there. So now we'll take the input value, multiply it by 5, and then that'll be the X for our movement. Now hit left and right, and I'm moving much faster. Cool. Now perhaps later on, somewhere else in this graph or somewhere else in the game, I would like to know what my speed value is. Well, the way I have it set up at the moment, I just have it hard-coded right into this B value to say this is the speed value. What I would like to do is create a variable that we can then define as our speed value, and if we need to, we can access that value later on. So I'm going to go to my object here under variables. I'm going to select object. This allows me to define a variable that is scoped to that game object, in this case, player. And I'm going to type in a name. The name is going to be speed. Hit enter. There we go. It's going to be a float value. So select that drop down, and I'm going to select float. Allows me to pretty much add in a decimal point value. And I'm going to say just 5 seem to work pretty good, right? So I'm going to add in a 5 here. And we're going to move at a value of 5. You can move as fast or as slow as you would like for your game. So 5. And now what I want to do is I want to assign this value as the input on B. So how can I do that? I'm going to grab this input node, and again, drag and drop. And now I can decide where it gets the value from. I'm going to type in get speed. And I can come down here and I can get the value of a variable by the name of speed. That's the name of the variable I created. Great. So do that. So now we're going to multiply the speed variable by the input result, take that out and add it to the X of our vector, and set the velocity every frame to be equal to that. Let's try that out. Works pretty good. What's happening here is the Y value is set to 0. And the Y, as you know, would be the up and down axis. So we're falling on the Y at a 0. And we don't want to do that. I want the physics engine to take over and handle what happens whenever we are falling. In this case, apply gravity to our character. So what I want to do for that is I'm going to take the Y value and I want to get the current velocity of our player. And this allows the physics engine to actually calculate the Y value for me without me having to do it. So if I were to get the velocity, I'm going to add another unit here, get velocity of the rigid body 2D, and this will output a vector, so an X and a Y, which is great. That's what I need. I need the Y value. But I only need the Y value. I don't need the X value. X is controlled by our movement with the keyboard or controller. So the Y value is all I need. So I'm going to drag this out here and drop it again. And I'm going to say get Y. Now go to vector 2, and that's going to get the Y value of that vector. So in this case, it's going to get me the gravity-controlled Y value. Now if I just sort of drag this into my Y here, let's see what happens now. I'm going to move off my platform, and I fall straight down by what looked like gravity. Great, cool. So what I want to do with this is I know later on I want to know if my player is moving to the left or to the right, or if he's moving at all, right? So I want to be able to take that value from the movement on the X and use it later on in this graph so we can actually handle animation, or we can handle flipping the sprite around so we can see that he's looking in the direction he's moving. So to do that, what I want to do is I'm going to take the value that we get from multiplying our input and our speed variable, and I'm going to store that in a variable that we're going to set for the graph, and then use that variable later on. And I'm going to just disconnect this vector 2 and the set velocity. We'll use this later on, so I'm going to leave it over there. We also want all this to go with it because we want to be able to still calculate the Y velocity for our rigid body. But notice now we don't have an X value, right? So what I want to do is set the X value to a variable and then get the value from that variable and assign it here. So I'm going to right click, add unit, and I am going to set a graph variable. Now a graph variable is scoped to this graph, so to the player controller, whereas the object variable, as we know, is scoped to the game object. Then all I have to do is type in a name. I'll call my variable movement, call it whatever you would like, and I have to pass in the value, and it's green because it takes an object type, which can be a float, a string, any type of object you can think of. We can just drag it right in and drop it. And now it's going to output the type of object that it received on the input side. But all I want to do is I'm going to remove the link from update to set velocity. And for this, I'm going to hit Shift Space to make my graph full screen because we have a lot going on here so I can see what's going on. And what I want to do is from the update event, it happens every frame again, right? I want to drag the flow control directly into the set variable. So now every single frame, I am going to be assigning the variable the value of our movement based on our input. And that's great. So now I have a variable set. Notice I never actually defined that variable anywhere. All I did was set it. And that's because Bolt allows you to dynamically create variables and assign values to them and then easily reference that value later on in the graph or the object. So what I want to do is do exactly that. Reference that value I just created. So I'm going to create a new unit here and I'm going to say get movement. Now that is the variable I just created that I can simply reference just like that. So I want to take this value and pass it into the X parameter on my vector 2. And now we're back to exactly where we were a second ago, except we have this disconnect between what's happening when we set the variable and whenever we grab the variable. And now what I want to do is pass the flow. Once we set the variable in this frame, I want to also set the velocity using that variable. And now if we look, notice I am moving. So we now have what looks like two distinct sections, right? This is for handling the input to get the movement, and this is for handling actually moving the player. So what I want to do is symbolize that section by actually holding down the control key and clicking the left mouse button and dragging. And I can create a section. I'm going to call this get movement. And now I have a group that is all tied to the movement container here. I can drag it around, pretty cool. And I also want to create a section for this chunk of units. And I'm going to call this set movement. And now what I want to do is I want to look to the direction I am moving. So if I'm moving to the left, I want to look to the left. If I'm moving to the right, I want to look to the right. So to do that, what we have to do is think about how we can get those values. So if we're moving to the left, we have a negative speed. If we're moving to the right, we have a positive speed. So we can use that negative and positive to actually scale our character on the X. So if we look at this, I have a scale value on my transform here. And on the X, if I were to make this 0, you cannot see me, right? I don't have any X scale. If I were to scale me to -1 though, I am flipped around because I am scaled all the way into where I've mirrored myself. So we're going to use that to actually flip our character around. And again, for this, we'll use the movement variable to determine which direction we're moving in. Get movement. And what we have to do is compare this to 0 to see if we are less than 0 or greater than 0. So the unit I'm looking for is comparison. And this allows me to do a bunch of things here. What I care about is, are we less than 0? Because if we are, we're moving to the left. If we are not less than 0, and we are in fact not 0, then we're moving to the right. And notice I am comparing the value of the variable to 0. So how can we do that? Let's take A is less than B. So we're going to say, if the movement is less than 0, I want to actually select a value. And the way we can do that is we have true or false here. So depending on the result of this comparison, we will assign a value to the output node of this select. So if we are in fact less than B, what I want to do is add a float that is -1, right? Because if we want to move to the left, we should scale on the X -1. If we're moving to the right, we want to scale on the X +1, just like that. And this is just the X value that we're scaling, right? We don't want to scale the Y or the Z. We don't care about that. So what we're going to do with this is we're actually going to go and add a unit, and we're going to get the scale on the transform and set it to whatever we come up with. So we're going to set the local scale of the transform component. And notice this takes a vector 3. Now I could pass in a vector 2 here, but that would result in the Y and Z defaulting to 0, which I do not want because then they'll be scaled at 0 and you wouldn't be able to see the player. So I'm going to pass in a vector 3, but I'm only going to care about the X value. So to do that, I'm going to drag this out from the vector input, and I'm going to create a vector 3, X, Y, and Z. And the reason I'm doing this is because I can set the Z and the Y to be 1 right inside of this vector constructor. And then for the X value, I just pass in the result of this comparison here so that we get -1 or 1 depending on what our movement value is. So let's see what's happening now if I were to drag this flow from set velocity straight into set local scale. So I move to the right, I'm looking to the right, looks good. I move to the left, and while I am moving, I am looking to the left. But if I stop moving, I default back to looking to the right. So let's fix that and see what's doing that. So what's going on here is there's nothing to check to see if we're simply not moving. Because if we're not moving, then we want to leave the scale at whatever it was whenever we stopped moving. So how can I do that? We have A is equal to B right here, which means if the movement is equal to 0, then this will be the result. So I want to take this output node and we're going to control the flow based on this result. And to do that, we're going to use a branch, which takes the flow in and says, if the value that you passed in is true, the flow goes this way. If the value you passed in is false, the flow goes this way. So what can we do with that? So I only care about this point if the flow is false, which means if we are in fact moving. So if the value is not 0, I want to update the movement. And I'm going to get rid of that connection and make the connection right into the branch. So that's going to handle where the flow goes, and then we're going to decide what we do. So for now, we only have the false value. So now let's see what happens if I were to go to shift space and then play. Now I move to the left. My guy looks to the left and he stops moving and still looks to the left, then back to the right, left, right, left, right. And you can see what's happening here with the selection, deciding which value to use. Pretty cool, right? Now what I want to do is tighten this up a bit and add another group. Call it flip. Great, so the next thing I want to do is actually animate the player. I want him to walk and animate at the same time. So if he's walking, he will play the walk animation. Luckily for us, our player already has the animation states set up for us. So we have the idle, then we transition to walk, then we transition back to idle. The way we do that is by detecting the float value for speed. So if the speed is not 0, then we're going to be actually animating the walk. If it is 0, we're going to be idling. So let's go ahead and set this up. Shift space. Again, for this, I need the movement variable. So I'm going to right click. I'm going to say get movement. And now the movement variable based on our speed variable is going to be negative, say in our case 5, or positive 5 for moving left to right. Or in fact, anywhere between 0, -5 and 0 and positive 5. But I don't care about the negative values. I only care if we're moving and at what speed are we moving, because the animation is going to play if we're moving to the left or to the right. It doesn't matter which one. So what I want to do is grab the absolute value of our movement variable, which is going to give us the positive value. So if it is a -5, it'll be 5. If it is 5, it'll be 5. So I'm going to type in absolute, and there it is. And now the output value will be a positive value. And what I want to do is take that value and pass it to my animator to set the float. So I could type in set float, and then on animator you have set float name value. It's going to take the name of the float you're setting and the value you're setting it to. So I'm going to select that. The name of the float is speed, and the value I'm setting it to is my movement value. Now, what's interesting about this is I want the animation to play if we have flipped the character around and if we have not flipped the character around. Since we have a branch right here that goes false for flipping and true for not flipping, I want to make sure I get it for the true, so I can pass in the control from true from that branch, and then as well as the flow from whenever we set the scale. And what's cool about this is we can drag and drop 2 flow control ports directly into 1 flow port for situations exactly like this. Now let's see what happens. And the walk animation plays if we move to the left or to the right. Pretty cool. And that's going to be it for this first lesson. Let me go ahead and wrap this up with a group around our animator like that. Now in the next lesson, we're going to start the jumping controls for our character, make him be able to jump, and also detect the ground, so we have to jump off the ground and can't jump in midair. We'll talk about that in the next lesson. My name is Austin, and I will see you there.